back and like, well, what if P1's 0 and, fill in some gaps. But once that's done, I think I have a pretty complete characterization of when those 4 equations I stated at the beginning can or can't be solved by an algebra substitution.
So that categorizes all two-dimensional, right?
Of that kind, yeah.
And then, so you're saying you could, in theory, do it to n dimensions and figure out a way to, like, get it, formal, and then you have a catalog of all algebras, all dimensions.
Well, again, it doesn't give us a catalog of all algebras. It gives us a test that, well, this is the weird thing. We just figured out that this function, z squared, right, is differentiable in a different algebra. Because A, P1 equals to that, P2 equals to that, is not, it's not the algebra we started with. It doesn't have unit 1, 2. It has unit, I think, E1, because it's the first case. It's weird. I don't even know if this algebra is isomorphic to the complex numbers. It's really outside my intuition, this result. So I don't understand. I don't. I mean, the theorem's true, but I don't understand it yet. What's that?
We can in theory just choose anything that equals the identity. Like we just arbitrarily chose 1, 2.
Yeah.
Pretty much just anything. There's no restriction on 1, 2.
No. Yeah, you can make anything the identity as long as it's non-zero.
Yeah.
And you haven't already decided to make I that. We cannot have I and the identity be scalar multiples. That much is forbidden.
So 0, like 0, 4, or 1, 4, 0, 4. We know that. Okay.
Yeah. Or we could do simpler, stupider stuff like the identity is not 1, 0, it's 2, 0. That would probably be a more productive place to have started. But then if I found that it worked then, I wouldn't have been very much convinced that it worked everywhere else. So I wanted to do something weird like this, because if I feel like if it can pass this, then, I mean, going forward, I'd like to also try like the hyperbolic 1, 2 identity, like a hyperbolic version of this, and see what it works out to. See if it actually is an isomorphic algebra. Is there any relation between this algebra and the original one? Like, what's the interplay? Like, what? If functions can be differentiable with respect to an algebra other than their own. I mean, what I'm trying to say is if functions are differentiable with respect to 2 algebras, is there any kind of connection between these 2 algebras? What is the connection? I have no idea, except I know that there must be. Here it is. I mean, here's a function which is differentiable with respect to the 1, 2 unit algebra and this P1 fifth, P2 4/5 algebra. Those are not the same algebra. They might be isomorphic. I don't know. Anyway, thanks, people.